Hi, my name's Peter Froment with Emerson Swan.
And I'm Kevin Shea, technical trainer at Emerson Swan.
Today we're going to go over the commissioning of a higher ductless mini split.
We'll also go through the pressurization and evacuation process.
Keeping in mind, if you are going to be doing any of this type of work, you need to be EPA 608 certified for refrigeration reclamation.
And also, we ask that you utilize the online resources, higherductlesshelp.com and emersonswan.com.
So now, we've done our installation of our line sets. We've already made our flare connections. So if we're doing a new install or if we're replacing an outdoor unit or an indoor unit, we still have to follow all these steps. So we've connected to the outdoor unit. We've connected to our indoor unit. We're now ready to pressure test this. So what I mean by pressure testing is we use a dry nitrogen to test the line set to make sure it's holding pressures up to 450 to 500 psi. The reasons why we do that is our 410A has operating pressures of in excess of 400 psi in the heating mode. So let's talk about some of the tools that we're going to need. First, we're going to need our nitrogen regulator, our nitrogen bottle, and we use dry nitrogen. I'll explain that in a moment. We also have our hose, system hose, and hose to our nitrogen. We also have our gauge. In addition, we have our adjustable wrench to be able to take the the service port nuts off. So why we use dry nitrogen is we are in essence trying to get any non-condensable, which is pretty much moisture. We want to get all of that out of the system, and dry nitrogen helps to displace that moisture. So you'll see when we do the next process here, you'll see a component of that come out.
So at this point, we're going to take and attach the bottle of dry nitrogen to the line set, and using incremental pressures, we'll build our pressure up to the required 500 psi. So first of all, let me start by attaching my nitrogen. And I'm going to again take our adapter so we've connected up, and we're going to go ahead and start the pressurization. We want to do it incrementally, and we're going to first bring it up to about 100 psi. So I'm going to open my gauge and watch my gauge port. My gauge itself, bring it up to about 100 psi. It's okay if it goes a little more. Okay, I'm more like around 120 psi, that's fine. So at this point, it's a waiting game. We just simply wait approximately 3 minutes, but we're also going to do a soap bubble test as we're doing our pressure testing. So we'll take the soap bubbles and spray all of our mechanical connections, and if all is good, we won't get any air bubbles. If we do get air bubbles, we'll stop the test, repair the flare or whatever's necessary, and then move on.
All right, one interjection I'm going to make here is that if you don't have a gauge set like this that has a combination gauge to it, and you have your typical 3-hose gauge set, this particular setup, what I would do is this, which is the high side gauge, would be closed. This would act as my system side pressure. This yellow hose I would take off, and that's what I would be connecting to my nitrogen regulator. Thus using the gauge here, the right side gauge, or the high side gauge, as my valve.
Okay, so while we're under pressure, I'm going to go ahead and take our soap bubble fluid and spray our connections. I'll be right back. I'm going to spray our inside connections. I'm very happy to say I see no bubbles at the moment. It's been about 3 minutes, 4 minutes. I'm still sitting strong at 120 psi. I'm going to go ahead and bump that up to about 150 now, a little over 150. Okay, it actually stopped at about 170 psi. So I'm gonna again wait that 3 minutes, maybe apply a little bit more soap solution and make sure that I don't have any leaks. So we've passed the next incremental test and we're gonna go ahead and bring it up to our 500 psi now. We were able to bring the pressure up to 485 psi. Now the regulator is set for 500, maybe it doesn't get all the way quite to 500, but that 485, that's a good number. We know it's a reference point. Now here's a little trick. So you don't fool yourself in your perception of the actual value on the gauge. Not a bad idea. Take your cell phone and go straight onto the gauge and snap a picture of it. And then that way, after we leave that test on for the manufacturer's required amount of time, then we can go back and take another snapshot and we won't fool our eyes. We'll be sure that we have a very accurate measurement. We've had that 485 psi in the system now per manufacturer recommendations. We have no deflection on the gauge. We've taken our second picture. We've compared our views on our phone. That gauge hasn't moved at all. And our mechanical connections have passed our soap bubble test. There is no foaming, no bubbles coming up. So we can feel pretty safe at this point that we've passed the pressure test. So what we need to do is secure and release the pressure in the system at this point. So the first thing we want to do is make sure that we shut off our nitrogen bottle and shut off our regulator. And at this point, we're pressurized at 485 psi in this hose up to this side of the gauge. So what I can do now is go ahead and crack this. Now, sometimes when we look carefully, we may be able to see some actual moisture being purged out. That's a good thing. That's what we want to see. If you have a high humidity day, good chance you're going to see it. If you have a very low dry day, you've pulled a good vacuum, you may not see that much. But either way, it's the ability of the nitrogen to absorb the water and release it, the non-condensables. So the other thing is, dry nitrogen as an inert gas is acceptable. We can release that to the atmosphere. So what we're going to do is go ahead and loosen up our connection. And as you may have heard, that just dropped our pressure down. There it goes. So now we have no pressure. In the blue hose, we can disconnect that. And then last but not least, it's a good idea to go ahead and turn the regulator back on. Actually, I gotta make sure that's off. Turn the regulator back on and release the pressure that's from the shutoff through the regulator. You may have heard that release. So this is safe to remove, take apart, put back into storage. Now, as you can see from this point out through to the line set, we are still pressurized. We have that 485 psi. So what I'm going to do is use my gauge to release that nitrogen to the atmosphere. But this is where I want to observe and see if I get any moisture coming out. So I want to give that a good blast. Open it right up and let that nitrogen come out. One other little trick. Before it goes to zero pressure, leave a tiny bit of pressure left inside the line set. That way you won't get atmosphere to pull back into the line set, because anytime you bring atmosphere into the line set, you bring in moisture, and then your evacuation process will take longer. So here we go. We're going to release the pressure, see if we get any moisture out of it. Sure enough, we got a nice little blast of moisture. I got about 10 psi. Bingo. So I stopped it with about 10 psi left inside this, maybe 15 or so, but just enough to eliminate the ability of atmosphere to get back into our system.
So at this point, we've completed our pressure test. So now we're going to move to the next stage, which is our vacuum test. Now what we're going to be doing with this is we're going to be doing the opposite. Instead of trying to push the flare nut up, we're going to be trying to suck the flare nut down and to make sure that there's no negative leaks in the system. Now we're still familiar with our gauge that's already set up, and we've got a little bit of pressure still left from the pressure test in there. And there's a reason why we're going to do that is, again, like Kevin said, is to not allow any non-condensables back into the system. But now we have to introduce the next components, the next tools that we need. So we're going to come down here. All right, now we're going to introduce our vacuum pump, our digital micron gauge. Okay, but before we get into the hooking this up and having Kevin do that, I want to talk a little bit about maintenance of our vacuum pump. Now, the vacuum pump is a must service item. What do I mean by that? This has oil, vacuum pump oil in it. The vacuum pump oil is hygroscopic. What does that mean? It means it absorbs moisture. If it gets to a point to where it can no longer absorb any moisture, it can no longer pull any moisture out of the system, thus you're not removing the non-condensables. All right, so you should change your vacuum pump oil after each install, especially if you have a high humid day. So we've done that, and Kevin's ready to rock and roll with this, so we're going to hook this up. We're going to hook up our digital micron gauge after we've started the vacuum, and let's get to it.
So at this point, we're going to go ahead and attach our evacuation pump, our vacuum pump, to our gauge. We're going to utilize the connection that we already have made and we know is a good tight connection. So at this point, I'm going to take my line from my vacuum pump and attach it to my gauge. Hoses are hitched up. We're ready to go ahead and turn that pump on. So this little plug is where the exhaust comes out. In essence, the exhaust, the moisture will be coming out. I want to go ahead, turn it on, open up my pump, my ballast, take a look at my gauge, open her up. Now remember, we had a little pressure left in there from before. And we could hear that vacuum pump when we opened it up change its tone, and you hear a little gurgling noise. That's all good. That's what we want to hear. So we're opened up, and my gauge lets me know that I'm in negative pressure. At this point, I can go ahead and attach my digital micron gauge. Now, a little trick, part of the reason why I waited until we created negative pressure is because we never want to apply positive pressure to our very sensitive micron gauge here. So at this point, I'm going to go ahead and get this connected up to this side of my gauge. Okay, so I'm going to go ahead and turn on my micron gauge, and the reason why we're using a micron gauge and not a standard gauge is we want an accurate measurement. Atmosphere is around 76,000 microns. We want to pull down the line sets to approximately 350. We want to be below 350, so 320 is a good number. So we want to pull our microns down to that point, and once we get below that point, around that 320, we can secure our lines. Now, the more moisture you have in the system, the longer it's going to take. So on a high humidity day, you might expect to be evacuating a little bit longer than on a dry day. The larger the system, obviously there's more atmosphere to evacuate. That's going to take a little bit longer than a little one-to-one unit with a relatively short line set. So once we bring the microns down to below 350, we have to secure it and hold that for the manufacturer's required amount of time. So really what happens at this point is patience. So a little tip, let your pump run And at this point, it'd be a good time to go and make your wire connections. So you can go in and wire up your indoor unit, wire up the outdoor unit, maybe you got a multi-unit.
So in this configuration, obviously we spoke before about having this gauge set up here, but some of you guys may have this style gauge setup. So I'm going to just talk about where these connections would go, how you would connect this up. So we have the system side coming here, coming around, and coming up to the bottom here of this gauge. Well, that would be as simple as doing this high side gauge hose, okay? So this one here would come around, you would attach this to the system. The low side here would be the one, once you attach it, would come down to the pump, to the vacuum pump. So now you have isolation valves. And this center one here, you would remove this yellow hose and you would attach your digital micron gauge here. So that will allow you to isolate the vacuum pump on this side while still maintaining the pressure and measuring the pressure in microns on this side.
Okay, so we're down at our 320 microns, and what we're going to do now is secure the pump from the system. With that closed, we're now going to be watching our microns and making sure that we don't rise within the factory required time. I put that there, and at this point I can shut off my pump, and we just have to wait. We've passed the evacuation test, so we've done a pressure test, we've done the evacuation test, so we can go ahead and remove all of our equipment from the service ports and go ahead and charge the system with the refrigerant. So I'm going to go ahead and remove my vacuum gauge and make sure that gets safe. And I can go ahead and disconnect my service port now. So, at this point, well, before I forget, we're going to also put the cap back over the Schrader valve and just give that a little snug. Okay. So, at this point, it's we're on a one-to-one system. We've measured the line sets. We're within factory specifications to not have to remove or add any refrigerant at this point. So what we're going to do is go ahead and at this point open up our line sets, balance out the refrigerant pressure, and we'll go ahead and start the test process with the performance testing on the equipment. So I grab my Allen wrench, remove my service port caps, and we can go ahead and open it up. Okay, so both of my ports are open now. When you get them to open, you'll feel it stop. You don't have to force it or anything, just leave it in that position. It's open, and then again, recap the service ports and just snug those up. So we're going to power back up. We'll put our disconnect in. And again, if I had my phone app, we could go ahead and turn this thing on remotely, but we're going to have Peter turn on the indoor unit and we'll start our performance checks. Pete, go ahead and fire it up.
We're going to test now the delta T. That's the difference between the temperature coming into the return side versus the supply side. Anywhere between 18 to 22 degrees is an appropriate delta T. Now, one of the nice things that Haier does is they have a thermistor up on the top of the unit, and if I open up this cover here, here's your thermistor right here. So this is actually sensing the return air temperature. Another nice feature that Haier has built into their heads is we can set this as either set point or return air temperature. Right now, currently, this one is set at the return air temperature. So I can see what temperature is coming back here. So that allows me not to have to take an additional thermistor, have it up here, measure it, and then go down here. It allows me to just literally take my thermistor here and go into my supply air side, my supply air stream. And what I'm looking for again is that 18 to 22 degree. Now we're going to let this here work a little bit, so I'm already over 10 degrees. Okay, perfect. We have now met a 20 degree delta from the return air temperature, so we're 20 degrees cooler for the supply air temperature. Now this is in cooling. If we're in heating, we're going to look for a higher delta than that. We're going to look for anywhere from 38 to 42 degrees. So this unit is done. We've commissioned it. So thank you very much. Thank you for spending your time with us. We hope you enjoyed the video. And as always, Emerson Swan Hire, we're here for you.
And that being said, don't forget to use the Hire Ductless Help app on your smartphone for all of the information, troubleshooting, line set, charge information, and also utilize emersonswan.com as a technical resource. Thank you.
Thank you.